So in today's session, we'll discuss about the change of system. Okay, so change of system is actually a unit which are used to what? Change between the main supply and the backup supply system. Okay, so mainly if you have a building, you'll be having a main supply system, it will be from the EB side, or you'll usually say from the transformer side. Okay, so if there is no supply from the EB side, you have to go for a backup. Okay, so that backup will be a diesel generator. So using that, we'll be taking the backup. So the switching between the main side and the DB side or the DG side, we'll call it changeover system. Okay. So for changeover, we'll be having mainly two classifications. The first one will be the main changeover system. Second is called the DB changeover system. Okay. So the main changeover system is the switching between the transformer and the DG. Okay, so this is the main change. So change over between or the switching between the transformer and the DC side. Okay, and the DB change system means the switching will be between the distribution board. Okay, distribution board and the okay DG. Okay, so we don't say normally DG in case of DB change system. It will be from the emergency panel. The emergency panel and the distribution board. So normally from the DG, the connection or the power will be coming to the emergency panel. From the emergency panel will be distributed to the distribution board. So switching between DG or I'll say emergency panel. Okay, emergency panel. That's it. Okay. And so the main classification, and again we have two sub classifications, that is AMF and load manager. So AMF means auto mains failure, and second one is the load manager. So both are actually will be censoring both DG side and the transformer side as well. Okay, the function or the purpose of this one is to, if there is no supply from the transformer side, it will automatically turn on the DG side. That's it. That's the purpose of both AMF and load manager. The difference is AMF is often connected to if you have a less number of connections. That means if you have one DG, one transformer, in that case you'll go for what? AMF. If your number of connections is more than two, if you have two transformers, 3 DG, or three transformers, 4 DG, in that case, you'll go for what? Yes, load manager system. So that's the difference, AMF and load manager. And in AMF, we have both full backup and partial backup system. Full backup condition means the building will be working in a normal condition, means in full load when it goes to the backup system. Okay. And partial backup means only for the selected components only will provide what? Backup supply. So that, for example, if you have the entire building, in some connections, we should give full backup itself. For example, the APFC panel, common panel, fire pump panel. So these are actually the mandatory connections you should provide full backup. Okay. Other connections like the common area lighting, or if it's an apartment building, in apartments for every connections we don't provide what? Backup. Okay, for if you take one apartment, one light, one fan, one socket, like that we'll divide or we'll distribute the connection partially. So that's the partial backup system. And in load manager, we only have what? Full backup only. Okay. And coming to the DB change system, again we have two sub classification, that is ACO and ACCL. ACO means automatic changeover. Okay. And ACCL means automatic current control limiter. So the purpose of these two is to what? Yeah, to channel the supply from the emergency panel to the DB. Okay, and how it is done? That's the difference. In ACO, how much supply we are getting, it will directly channel to the distribution board. Okay. In ACCL, there will be a limit will be there. Suppose based on our usage, the DG can adjust its or DG and what? Reduce its working. Suppose if you require more power, DG will operate more and it will provide more power. And if you use less, automatically the DG will what? DG will reduce its working. So thus you can save some fuel them. That's it. Okay. That's the difference between ACO and ACCL. Okay. And both have full backup as well as partial backup system. So then overview about the changeover systems here. Okay. And yeah, this one is our AMF system, and this one is a load manager, and this one is our ACCL and automatic change system. Okay, and in a building we'll be having both. Okay, both main changer system and DB changer system. Okay, main changer system will be switching between DG and transformer, and when it comes to the SSB or SB side, we'll be having what? Yeah, DB changer system. Okay, and now okay, I'll explain the schematic how the systems are working. Okay, how the MF backup and full backup, partial backup is working. So first thing I'll start from the transformer side. Okay, when means the normal condition. Okay, so you'll be having supply from EB and the connection will be coming to the transformer. Transformer will step down and distribute the power to all the panels we have, right? So here, in the normal condition, we'll be having supply like this. Okay, and the transformer will be in on condition. Okay, so transformer is in on condition. Transformer is in on condition. And the supply will be coming to the ACB. So in the normal case, ACB will be in on condition. Okay. ACB will be in on condition and the supply will be coming to the bus bar and it will distribute to all the panels like this. Okay. So SB1, fire pump panel, common panel, APFC and SB2. Okay. At the same time, the DG side, this will be in off condition. Okay. So on the normal side, the transformer side will be on and the DC side will be off. Okay. And if there is no supply, okay, so let's assume there is no supply from the transformer side, the AMF will detect that. So AMF is actually connected to both the transformer side and the DG side as well. Okay. So if there is no supply from the transformer side, AMF will sense that and that will send a signal to the DG and the DG will be turned on. Okay. So once the DG is turned on, our ACB will turn on. Okay. ACB will turn on. Then it will provide supply to all the panels like this. To the SB2, APFC, common panel, fire pump panel, and the SB1 panel. Okay. And once the transformer is, once the DG is turned on, this ACB will turn off. This is to prevent the backward flow of the power. So if it is turned on means the power will go back. So we don't have to do that. So we'll turn off this one. So that's how the AMF full backup system will be working. Okay, clear. Now the next one is our AMF itself. That's a partial backup system. Okay. So here same way, I'll explain from the normal side first. Okay. The normal side, supply from the EB and the ACB will be in on condition and the supply will be coming to the SB1 panel. And here you can see that there will be one more contactor will be placed. So this is the contactor one, or it can say it's an isolator itself, and the isolator two. So in the normal time, okay, the first contact will be in on condition so that the supply will be coming to this panel like this, and it will be going to the common panel, then to the APSC panel. Since the second contact is off, it will not go to this side. So it will be ending up to here. So SB1, fire pump, common panel, all APSC. So these are the only connections will be connected in the normal time or when we have the supply from the transformer side. Okay. And If there is no supply, you have the AMF here. AMF will detect that and it will turn on the DG. Okay. So once it is turned on, our transformer side ACB will be turned off and this contactor will be turned off. Okay. And the remaining two contactors, okay, we have one contactor over here that will be turned on and the ACB will be turned on. Okay, so that supply will be coming to through here and first it will go to the emergency panel. Okay, then after that this is on, right? So that will go to the APOC panel, common panel and to the fire pump panel. And here you can see that this contactor is turned off. That means no more supply will be given to the SB1 panel here. So this is the partial backup system. So only these three components are given the backup. SB1 is what? Excluded from the backup system. But we have a emergency panel here. So from the emergency panel, we can provide what? Only for the essential components, we can provide the supply from the emergency panel to the SB1 panel. This one is our DB changer system. The switching between the DB and the emergency panel. Okay. And again, it's not necessary. If we have that, we'll provide, or else we'll be using for something else. Okay. And if it's an apartment, in every apartment we don't provide, only for the necessary components only. In if you take one room, one light, one fan. In bedroom again, one light, one fan, one socket. Like that only we'll provide. And for power loads, we don't provide backup. Only for light loads only we'll provide what? The backup system. Okay. So clear this one. AMF partial backup. Okay, so moving to the next one, that is the load manager. So load manager, it's full backup. So in load manager, we only have full backup only. There is no partial backup. So as I explained before, load manager is used if you have a number of transistors more than 2 DG, 3 DG, two transformers, three transformers. In that case, only you'll go for what? Load manager. And for this one, I'll just show on 2 DGs and one transformer here. Okay. So start from here, from the transformer side. First, 3CB will be in on condition. Okay, so that it will go to the bus bar panel here. And again, we have one more ACB that is placed here as well. Okay. Here you can see that one more ACB is here in between the bus bar, and that one also will be in on condition. So similar case we already explained in the last class. And from here, connection will be going to the fire pump panel, SB3 panel, SB1 panel. Again, we have common panel, APSC, chiller, and SB2 panel. So transformer will take care of all these panels alone. Okay. And when it comes to the backup side, we have load manager here. So if there is no supply from the transformer side, load manager will sense that and it will send signal to the DG1 and to the DG2. So both the DG will turn on. Thus, it will turn on the ACB of both sides from the D side and it will turn off the ACB from the transformer side. Also, you can see that there is one more ACB which is placed in between. That one also will be turned off. I'll explain why. So that the the DG1 will provide backup to these panels, SB1 panel, SB3, fire pump, and common panel. So since it is turned off, it will go to this side. And DG2 will provide backup to SB2 panel, chiller panel, and APFC panel. So this is how you provide, or this is how you what balance the routes. Okay. And if you want, suppose if let's say if one DG is not working, Okay, so in the buildings like the hospital, shopping malls, every time, everywhere, we'll be having a backup DG also. If one DG is not working, we'll be having a standby DG. Okay, but in some cases we don't do that. But in essential components or the essential spaces, like critical conditions like this, will provide a backup DG as well. Okay, let's say if one is not working. Okay, but we can see that there are APOC panel is there, chiller panel is there, common fire pump. So these panels we should provide what? Mandatorily backup should be provided. SB1, SB2, and SB3 can be excluded here. So what you can do is, in situation like this, we can run DG1 here, and we can cut off the supply to SB3, SB1, and SB2 panel. Okay. Then once we balance the load, we can turn on this ACB manually. Then the supply will be given. Yeah, we can provide supply like this to the fire pump, to the common panel, to the APSC, and to the chiller. So like this, you can provide supply if required. Okay, but one thing to remember is the load should be balanced. If there is no load, means it will not carry that. If the load is balanced well, you can work like this. Okay, clear. And the next one is ACO and ACCL full backup. So both concept is same and the schematic is also what same here. Okay. And this is the diagram for schematic for full backup, and you might have familiar with this schematic. We already discussed in previous classes. And in this case, we'll be having a main income isolator will be there. Then we have the fuse, energy meter, circuit breaker. This is the change of system. Okay, this is the change of system. Then again, one more circuit breaker, then the panel. Okay, so in the normal condition, the supply will be like this. You'll be having supply from the, okay. So in that case, normal condition, the first circuit breaker will be in on condition. Okay, this circuit breaker will be in off condition. Okay, then we have the changeover. Changeover, you can see that we have two contactors are provided. First, the contactor is there, then below that we have one more contactor. So in the normal condition, this will be on condition. Second one will be off condition. So that the supply from the transformer will be coming through like this. And it will be given to the panel. So both are off. The contactor is off here, so it will not come to this side. So it will channel through here and it will be connected to the DB. Okay. And in case of backup, so you can see that this is from DGSP means DGSB panel, or let's say emergency panel itself. So from the emergency panel will provide supply. And in this case, supply will be coming through here. Okay. And it will go to the bus bar here. This bus bar. So in this case, the bottom circuit breaker will be in on condition, top one will be off condition. And the first contactor will be in off condition, second contactor will be in on. So the power supply will be going like this. Okay, to the panel here. So that's how the normal condition and how it will be supplying through the backup condition as well. Okay. And one more thing is why we have two circuit breakers means for this circuit breaker, the first one will provide protection from the transformer side. Second circuit breaker will provide protection from the DG side. If there is any over current or any short circuit happens from this side, this will give protection. That's why we have two circuit breakers in row. Okay. And finally, the partial backup system, AC and AC are partial backup system. And same way here, the normal condition will be having supply from here, and the connection will be going to first the fuse energy meter. Then we have circuit breaker is here. Same way we have two contactors. In the normal condition, both will be on condition. The circuit breaker will be on. Both the contactors will be on condition. So that will go to directly to the panel. And in the backup time, you can see that from the DG, the supply is coming from here. At that time, the first contactor will be in off condition. Second one will be on condition. So that supply will go through like this. And one thing to remember is not all the connections will be connected. Only light loads will be given backup. Okay. And again, in this case, we don't have any what backup circuit breaker here. From the backup side, there is no protection, but it's not like that. We have, but it's not shown here. It will be from the emergency panel. So if you come to emergency panel, here, yeah. So we already have one what MCCB placed here. Okay, so if there is any short circuit or overcurrent coming from the DC side, this will go to trip condition so that they will not supply going to the SB1 or to the DB side. Okay, so we have that, but it's not shown. So yeah, these are the circuit breakers. Sorry, chain systems we have. Clear? Any doubts? Okay, so I hope this one is okay. So I'll move on to the next one. So next one is UPS, that is uninterrupted power supply. So right now we discussed that the DG we have used for backup is the, so okay, we have the DG, but every time we cannot depend on what the DG is for the backup. Okay, so if you consider a office space or a, we have a server rooms will be there. So in office space, server rooms will be given UPS backup will be. Even if we have DG, server rooms will be have what? UPS backup will be there. Or in case of a hospitals, will be having, even if we have DG, the condition like operation theaters, ventilator, incubators, in those scenarios, we'll always have what? A UPS backup also. Okay, because those are critical or mandatory conditions we have. So we'll go for a UPS system as well. And UPS will be having mainly two parts. That is, a rectifier will be there, then a inverter. So those are the two components in the UPS system. Then we have batteries to store the energy that we have. And the purpose of the rectifier is to convert the AC supply to or AC voltage to DC. Because we know that AC is alternating current and it's always fluctuating. Okay, so it's not constant, that will be always fluctuating. So we cannot store AC voltage. Okay, so that we have to convert the AC to DC. The DC can be what? Stored in batteries. AC cannot. Okay, AC is only used for transmission only. For the saving or to store the energy, we have to go for what? We have to go for DC. Okay, so once you convert, that energy will be stored in batteries. And next component is inverter. The purpose of the inverter is to convert DC back to AC because the most of the components will be using like the light, ceiling fans, electrical equipment. All electrical equipments are working in AC, right? So that we have to again convert the DC back to AC. Then it will be going to the load here. So that's how the simple schematic of a UPS system is. Okay, and in UPS we have only two types. One is called the online system. Second one is called the offline system. Okay, here let's start with the offline first. Okay, offline system. Let's start from. So you'll be having an incoming supply. Okay. So the incoming supply will be directly going to the a changeover system. And in this changeover system, we'll be having, we'll go to the load here. That's all the normal supply. So from the normal supply system or the DB side, it will be normally going to the panel and to the changeover system, then to the load. At the same time, we will take a tap connection. From this tap, we will connect to the UPS, especially to the rectifier. So the rectifier will convert the AC to DC, and the backup will be, or the power will be stored in the battery. When there is no supply, the changeover will switch back to the UPS side. Okay, so we can set a timer for that or a changeover system, automatic changeover system for that. If there is no supply from here, it will switch back to the UPS side. And in this case, from the batteries, it will go to the inverter. Inverter will convert DC back to AC, and it will go to the load. Okay, so that's how the offline UPS system is working. Okay, and mostly in residential spaces or in small commercial spaces, we use what? Offline UPS system. And the disadvantage is there will be a time lag will be there, because when there is no supply, it will switch back to the UPS. At that time, all the components will turn off for a second. Okay, the timings will vary depending upon the UPS and the timer you are setting. So there will be a time lag between the switching between the normal side to the UPS side. So all the system will turn off for a second, then it will come back. So that's how the offline system is working. Okay. But when it comes again, so that we cannot use these systems in what? The IT system, IT server rooms, and all the above mentioned conditions, you cannot use the offline system because of this time lag or the switching gap is there. Okay. In that case, we will go forward the online system. Okay. So the online system will be first, the supply will be coming from the EB side. Then it will directly go to the UPS system. In this case, you can see that it is directly going to the load from where we are charging the battery. That's it. From using a tap, we are charging the battery here. But here there is no like that. It will directly go to the UPS system. From the UPS, first rectifier will convert DC to DC and it will store in the battery. And then it will go to the inverter, then it will convert DC back to AC. From here, it is going to the load. Okay, so same like what you can say, you'll be charging the laptop at the same time you'll be using the laptop. Same like that. At the same time it will charge. At the same time we can what? Use that one also. Okay. And when there is no supply, you can see that the supply will cut off from the normal side, so that from the battery, the load, or from the battery, the supply will be given to the load directly. So here there will not be any time lag if you compare with the offline system. So that's the advantage of online UPS. Again, comparing to the offline, it is costly, but the purpose is what served here. Okay. So that's our difference between online and the offline system. Okay, clear? So yeah, these are the two type of UPS systems we have. Now let's see how to select a UPS or how to select a battery depending upon our backup time and the connector load we have. Okay, so a small example is given here. So design a UPS for a 300 watt lighting load of and 3 fan of 70 watt each and a LCD TV of 200 watt and home theater again 200 watt and a juice extractor of 150 watt with a 5 hours backup. So these are the components which you are supposed to connect to the UPS backup system, and we need a backup for at least say 5 hours. Okay, so now first thing we have to calculate the total connected load. Total connected load of the building or the components you are supposed to connect to the system. So here already given here just to what? Add the load. So 300 plus 3 into 70 what means 3 fans of 70 each. So 3 into 70 plus 200 plus 200 plus 150 for this one. We'll have 1060 watts. So 1060 will convert to kilowatt, just divide by 1000, you'll get 1.06 kilowatt. Okay. So once you have calculated the kilowatt, you can convert, you can find a 10% factor safety, because again, apart from this one, in future, if you are adding anything else, just to be in the safe side, you can add a factor safety for this one. Okay, so factor safety, depending upon the client preference or the chance of upgrading, you can add more. So now 10 is taken, you can take 20 or 25% also. Okay. So that 1.06 into 1.1 will get 1.166 kilowatt. Okay. Now, next step, we have to choose a UPS. Okay. So you can see that there is no system which will be giving 100% efficiency. Okay. So for that same way, the UPS also have what? A certain efficiency will be there. Okay. So it will vary depending upon the manufacturer or the brand. So here I'm just considering a 90% efficiency for my UPS. Okay, so that 1.166 divided by 90% means 0.9. I'll have 1.3 kilowatt. So this will be the final connected load. Because if my UPS is having a 100% efficiency, I can take 1.166. But it's not. It's a only providing a 90%. That means 10% is loss. So in that case, I have to go for what? A 1.3 kilowatt will be the total load. Okay. After that, we can get to the UPS rating, and UPS ratings are given or available in kVA rating. That means we have to convert this kilowatt to kVA. So we already have the equation, that is maximum equation, total control divided by diversity factor into power factor. And one more thing, here it will be a constant condition in case of backup. So that 1.3 divided by 0.8, you will have 1.625 kVA. So that the UPS again, if you got 1.625 means it's not necessary to have a 1.625 kVA UPS. So you have to check for the catalog of any manufacturer, ABC, God. So any manufacturer you can go for. From there, you can check for the available ratings. So I think after 1.6, 1.8, now 2 kV is available. So you can check it and finalize the UPS rating. Because I'm going to assume I should have a 1.8 kVA UPS. I'll finalize here. If available, if 1.7 is available, you can go for 1.7 also. Okay, so we got the UPS rating. Now next we have to get the battery capacity. Okay, so for battery capacity we have an equation, that is T into kVA divided by voltage into number of batteries into efficiency of the battery. T means time. That means our backup time. It's already given here, that is 5 hours. I should provide 5 hours backup. Into kVA is our kVA is the rating of the UPS. What is our rating? UPS rating. The same we can provide. Divided by voltage means voltage of the battery. So usually we'll provide what? 12-volt batteries. In the residential or small commercial place, we'll go for 12-volt battery. Apart from that, we have 24-volt is there, 48-volt is there. Okay, so those will be going for the more industrial application. For now, we can take what? So this one is residential space. So we can finalize, let's say 12-volt battery will be there. N means number of batteries. So how many number of batteries are required? Okay, so this one often started based on the space we have. So if you are space which you are supposed to accommodate the UPS system, if you have more space for the battery, you can take multiple numbers. So minimum, uh, on an average, you can take two numbers. Two or three is fine. If you go for one battery, means size will be bigger. Also, if the battery is gone, means it will affect the entire system. So that it's always better to go for two or more numbers. Then finally, E is the efficiency. Again, same way. Batteries also have what certain efficiency level. It will vary from 80% to 95%. Okay, again, depending upon the brand or the manufacturer, efficiency will vary. And how to get that means we can get from the product catalog itself. Okay, Exide, Amaron, any brand you can refer. So from there you can get the efficiency of the battery. Okay. So these are the parameters we have, and we have the all parameters, that is time is 5 hours, kVA capacity of the UPC is 1.625, and here it's given in kVA, so we have to convert to volt ampere, so just to multiply 1000. Okay, divided by voltage, we have set a 12 volt batteries. The number of batteries I'm selecting a two numbers here, and efficiency I'll go for a 0.9, means 90% efficiency. Thus, once you substitute all the parameters in our equation, you'll get 376.16 ampere hour. So ampere hour is the unit for the batteries. Now, when you say mobile phones, you'll say mAh, milliampere hour. Okay, so it's a small battery, so you can say milliampere hour. Here it is ampere hour. Okay, so that's our capacity of one battery. Okay, so we have selected two numbers here. That means one battery capacity is 376.16 ampere hour. Okay. So if you want one battery, means you can divide with one. So you'll get the capacity of one battery. Okay. If you're going for one number. So that's it. This is our calculations to find out the or selection of a UPS and the battery. Clear? Any doubts?